Our second to last endocrine organ that we'll talk about is the adrenal gland. The adrenal glands are paired glands that are located on top of the kidneys, so on the right and left kidney. And they are pyramid-shaped glands that contain an outer cortex and an inner medulla. The adrenal medulla, the inner region, is what the hypothalamus stimulates when we enter a stress response. And so it releases epinephrine and norepinephrine during sympathetic stimulation. So when we enter the sympathetic system and we're going into a stress response, epinephrine and norepinephrine are released, and they're going to move into our blood and cause increased heart rate, increased pupil dilation, increased awareness of our environment so that we can either fight or flee. The cortex then is the outer region, and it contains cells that release either glucocorticoids, mineralocorticoids, or androgens. Glucocorticoids, the main ones are your cortisols and your corticosteroids. Mineralocorticoids, the main one is aldosterone. And then the androgens, the main androgen is testosterone. Cortisol is released in the stress response when we have stressors that last for longer than just a few hours. These stressors, and so when you think of normal stressors, might be exercise or something scares you, you're driving in a car and someone almost hits you and you go into that stress mentality, fight or flight mentality. You're walking along the road and a dog jumps out and barks at you and scares you. Those are things that would initiate the stress response. And typically, the stress response is going to be over very quickly. With exercise, an hour, 2 hours at the most. But when the stress response lasts longer, so stress of being in a nursing program, that might be an example, or the stress of being ill, then you're going to use cortisol to increase the amount of glucose in your system so that your body can fight for a longer period of time or stay in that stress area for a longer period of time. Mineralocorticoids, specifically your aldosterone, function in maintaining the ion balances of different minerals. So the aldosterone functions in monitoring sodium ion activity. And so when aldosterone is released, it increases sodium uptake so that we don't lose as much sodium in our urine. This also increases the amount of water that we take back in, so it increases our blood pressure and decreases the amount of fluid we lose in urine. So this is really important because if we don't do this, then we would dehydrate very rapidly. And then we have our androgens, mainly testosterone, that help in monitoring secondary sexual characteristics, help in bone production to some extent, and mainly do the same thing as testosterone from the testes. So help in sperm production in males. In females, it doesn't have as much of an effect because we have a lot of estrogen and progesterone that does the same thing for us. I just mentioned all of these, but here's an example of glucocorticoid activity. So again, we have a stimulating hormone from the hypothalamus that stimulates the anterior pituitary to release ACTH, adrenocorticotropic hormone. This stimulates the adrenal cortex to secrete cortisol, and cortisol is going to be released into the body, into the blood. This is typically associated with decreased cortisol levels and increased stress levels. The increase in cortisol in our blood is going to increase glucose production by the liver, so gluconeogenesis, producing new glucose molecules from other molecules, fatty acid breakdown, amino acid, or protein breakdown into amino acids. And then these amino acids, these fatty acids, are going to move to the liver, and we're going to produce new glucose molecules with them. So this allows us to resist stressors for a longer period of time, for weeks or months even, depending on what the stressor is. Here's your mineral corticoids. So aldosterone being the main one. If you're dehydrated or you are you have a decrease in sodium in your system, this decreases the amount of blood that we have, because decrease in water decreases the amount of blood in our system, because most of our blood plasma, is water. This decrease in blood volume decreases our blood pressure, and this stimulates the kidneys to increase a different molecule called renin. Renin activates the liver to produce, or activates a protein produced by the liver called angiotensinogen to produce angiotensin 1. Angiotensin 1 is going to be converted into angiotensin 2 in the lungs. And angiotensin 2 increases blood pressure by increasing constriction of the arterioles of the blood vessels themselves, which that will increase blood pressure. But it also, angiotensin 2 stimulates aldosterone production, and aldosterone increases the amount of sodium we take back in, and then water we take back in. And this will increase the amount of blood we have, which increases our blood pressure back to normal. So, very intense figure. You'll understand this, I'm sure, when we get into the blood chapter, because I'll talk about this again in that chapter. I'm going to let you watch this video on your own. It's all about the adrenal glands, and all you have to do is be on the internet, and you push this button, and it will work, okay? So the last thing I'm going to mention is your adrenal glands function in your stress response. And so what is stress? Stress is anything that upsets homeostasis. So it can be injury, it can be depression, it can be something that emotionally affects you, it can be something that physically is affecting you, like exercise or pain. And we handle stress by this process called general adaptation syndrome, or the stress response. This was discovered by Hans Seeley, and he came up with the 3 stages of stress, the stress response. He did this in the early 1900s. There are 3 basic stages. The alarm stage is when the hypothalamus triggers the adrenal medulla to release epinephrine and norepinephrine. This is the first stage of the stress response. We're going to be flooded with these hormones that increase heart rate, increase oxygen consumption, so breathing. It's going to increase our dilation, pupil dilation, so we can see everything. So we are able to either fight or flee from whatever stressor we are dealing with. This response lasts just for a few hours. Then, once we use up all of our glucose in our body enters the stage of resistance. Stage of resistance is the longest period. So stage of resistance starts when we use up our last glucose reserves, so glycogen reserves. Then we release more cortisol, and cortisol helps us to maintain glucose levels in our body. And it does this by breaking down fats and proteins and converting them into glucose. So cortisol causes fat breakdown, protein breakdown, and then a process called gluconeogenesis occurs, where the fats and the proteins that were broken down are converted into glucose that our cells, specifically nervous system cells, cardiovascular cells, can use for energy production to increase our ability to function during the stressful time period. If we do not leave that stressor, the last stage is called the stage of exhaustion. I'm showing you this. This is the information I just talked about. Okay. All right, so we've talked about alarm, we've talked about resistance, and now we're going to the stage of exhaustion. At this point, we've used up all of our resources. Exhaustion is going to lead typically to the death of the individual. So if you enter the stage of exhaustion, you have depleted all reserves that you have, and now your organs no longer can function properly. And what that means is organs like the kidneys, organs like the heart are no longer going to be able to work like they're supposed to. And so it says days to weeks. Typically you're looking at very short period of time. Once you enter the exhaustion stage, you're going to be on a decline until death of the individual occurs. So it's sad. Typically, we move into the alarm stage multiple times on a daily basis. Stress is important. I mean, it keeps us moving. And we also move into that resistance phase every once in a while. But eventually, we move back out. Some disorders associated with the adrenal gland, Cushing's syndrome and Addison's syndrome. So Cushing's syndrome is an increase in glucocorticoid release. So this, because it increases the amount of glucose in our system, can actually lead us to obesity, high blood pressure, and eventually diabetes. Addison's disease is a deficiency in adrenal production, adrenal hormone production. And when you don't have enough glucocorticoids, you're going to have weight loss. You don't have enough sugar in your system, so you're going to have low blood sugar, fatigue, hypotension. Typical treatment for Cushing's syndrome is going to be potential removal of the adrenal gland and then hormone replacement therapy. For Addison's syndrome, you're going to have oral corticosteroids given to increase the amount of cortisol in your system so that you start producing more sugar so that you don't have that low blood sugar. You're not as fatigued. You can gain weight back to where you're supposed to be. All right, I'm going to stop here. We have one more organ that we'll talk about, and that's the pancreas, and it'll be for my last mini lecture. So see you in a few moments.